Hello. We'll talk mainly now about like how machine language is and how the instructions are sequenced. This would be kind of like foundation of computing where the world of machine language and instruction sequencing is done. Think of this way. When you and I talk, we use English, probably Hindi, or in some cases Marathi. But when we talk to computer, it doesn't understand the words. The only language it truly understands is the machine language. That is zeros and ones. So what machine language is, that's what we are going to understand in this session. Then further we'll talk about how CPU architecture affects the instruction. Then we will talk about the structure of machine instruction. And towards end, we'll be talking about how instructions are sequenced through the fetch, decode, execute cycle. By the end, you will be able to understand why machine language is said to be heartbeat of every computer operation. Imagine electricity flowing. Like it can be on or it can be off. That's the essence of computer thinking. Zero and one. Machine language is the most basic programming language written entirely in binary digits. Each sequence of bits represent a very specific command. The CPU doesn't need a translator when reading the machine code because it executes it directly. But here is the catch. Every CPU has its own unique machine language. And that's why code compiled for an Intel x86 chip won't run directly on ARM processor without translation. Similarly, we saw the same like in earlier demo when we talked about ARM programming. Like when we translated our C code to ARM executable or binary, we saw that it was giving us error because Intel architecture could not understand the instruction set. So machine language acts as the direct bridge between software and hardware. So let us understand why does machine language power every computer. Think of it like the foundation of building. You don't see it every day, but without it, the whole structure collapses. Every high level language like Python, Java, C ultimately translates down to machine instruction. So the basic crux is the binary code, the language of the CPU, which is made up of instructions that the CPU can understand directly, permitting hardware to perform basic operation instantly. Then machine language bridges the code and hardware. It converts human readable programs into commands and the hardware can execute, making sure that program works as intended. Okay, then instruction sequencing ensures that the commands are executed in correct order. And then understanding the machine language deepens the programming insights. So when you click on app, when you play a video game or send a WhatsApp message, it's really billions of machine instructions executing in the background. Now let's step into CPU's world. The CPU architecture is like the design of a city. It defines the rules of how things move, how houses are built, and how services are accessed. There are two dominant CPU design philosophies which we talked earlier too, like CISC and RISC. CISC, complex instruction set computer, and RISC, reduced instruction set computer. So we talked about CISC saying that there are few instructions in a program, but each instruction is a complex. Examples like Intel x86 and AMD processors. Advantage is like code is very compact. And one can say cons or disadvantages like instructions take longer to execute because decoding is harder. And in RISC, which is reduced instruction set computer, many simple instructions are there, each executes very fast. Like example, we talked about ARM, which is mostly used in smartphones. Then there can be thought of like MIPS architecture or RISC-V architecture. Advantages like it is easy to decode and it is faster in terms of execution perspective. But cons like disadvantages requires more instructions per task. So if we think of it like CISC would be giving someone a detailed recipe, say for example, cooking biryani, which includes cutting onions, marinating vegetables, cooking rice, all in single instruction. And risk, whereas, is like breaking it into small steps. Cut onions, marinate vegetables, and then cook rice, which is faster to follow, but it requires more steps. Programs are stored in memory as a sequence of machine instructions. Machine instructions tell the CPU exactly what to do, like load, add, jump. That's what we saw earlier too. Use the binary precision to manipulate registers and memory, and it executes with unmatched speed and accuracy. Every action in our system, like even moving a mouse cursor, is powered by this invisible dance of instructions. So let us try to understand the anatomy of machine instruction. A machine instruction has basically three key parts. Operation code, like opcode. What action should the CPU perform? Operands, the data and or memory addresses the operation acts upon. Like for example, we saw an instruction where we wrote, say for example, move EBX, 1, but the instruction got translated to something like BB 01000000. Now, if we recall this particular translation, like of move EBX, 1, saying BB 01000000, in this case, BB is the opcode and 01000000 is the Little Indian conversion in binary form for a value 1, which is converted later to hex. Notice instruction sizes vary by architecture. Like with ARM, we saw that it is fixed length. It is easier for decoding, but x86 varies in length. There are different components included when we talk about instruction formats. The CPU is rightly called as brain of the computer. Now, if we break it into small major parts, there are registers, which are tiny but extremely fast storage locations, like our notepad while solving a mathematical problem. Then ALU, arithmetic logic unit, the calculator inside your CPU. It adds, subtracts, and makes logical decisions as well. Then there is program counter, that is instruction pointer, which keeps track of where we are in the program. Like for example, bookmarking in a novel. And together, these components ensure the CPU never loses its place and processes the instructions in lightning speed. Instruction sequencing is done through fetch, decode, execute cycle. Now, here we will address how instructions are actually running. The process is known as the instruction cycle or fetch, decode, execute cycle. Now, here let us try to decompose these words. Fetch. The CPU retrieves the next instruction from memory using the program counter. Decode. The CPU interprets the binary pattern. What does the instruction mean? And execute. The CPU performs the required action, whether it is arithmetic, moving data, or even jumping to another part of the program. And this cycle happens billions of times per second in modern processors. It is like the heartbeat of the computer, like fetch, decode, execute, repeat. To wrap up, let us take an example. Let us say I have a text, Savitri by Phule University. So what it would be if I had to translate it, then what your processor does? First, it creates it as a string. Like think of this as a tabular format for this word, Savitri by Phule Pune University. Now each character will have associated ASCII value. So ASCII code is taken. Now this ASCII would be converted to binary in 8 digit. So like for example, for capital S, it is 83. It would be converted to 0101000011. 01010011. Now if we see, if we divide this into 4 bits, then accordingly the hexadecimal conversion is done. Similarly, if I talk about A, which is ASCII code for it is 97. Now you convert 97 according to the binary conversion, and then you pick from LSB towards MSB 4 bits and convert that to an hexadecimal number. You get 61. So one can see, if I have to write this Savitribai Phule Pune University with space in between every word, rather after Savitribai, then after Phule, then after Pune, then one can see that this text would be written in full binary form like this. Now it like if I don't give you this text, say, and if I ask you, can you please convert this binary to text? You definitely can do that, but it will take some amount of time. But one can see like why we don't use machine language and why programming languages are written in English like form, like what we call as high level or middle level languages. Now the machines, what they do is whatever the hexadecimal forms are, like this binary would be converted into hexadecimal. Now to wrap up, one can say machine language is the main native language of the CPU. The binary commands that drive every action. And we know that CPU architectures like RISC define how instructions are structured and executed. Each instruction has an opcode and operands, which would be we already have seen. I will try to show you probably again in the next recorded session. The CPU with its registers like then ALU and program counter brings these instructions to life. And finally, the fetch decode execute cycle ensures that the CPU continuously processes instructions in a precise sequence. So for example, like one can say every modern application, every website or even AI tool boils down to billions of zeros and ones running in machine language. And this is what we have to remember. Everything that we speak would be translated into binary and then would be again decoded, encoded kind of thing. And that's how you listen it. Correct. And this is exactly how your computer thinks. Like here, I took this text like Savitribai Phule University. It is readable to us, but machine would be understanding in terms of either binary or hex, what is called as machine language.